Today we're going to look at circumcircles. Circumcircles are simply a circle which is inscribed through the points or the vertices of any triangle. So if I draw any triangle, I can always create a unique circle that goes through all three of the vertices. Now to demonstrate this, I want to show you an example in GeoGebra. So if I take any 3 points, A, B and C, and I connect those using line segments, if I take the perpendicular bisectors of these lines, I find a point of intersection. Now that point of intersection is going to be at the center of the circle through each of these vertices. Now the lovely thing about GeoGebra is that it's a dynamic geometry sketchpad, meaning these points I can move. So I can pick up my point C and show you that no matter where I move that point C, the circle that I've created will always go through the points A, B and C. That also happens if I move the point A, and it also happens if I move the point B. So now that we've seen the process visually, we're going to do this algebraically. So we had 3 points to start with, A, B and C. The first thing we were to do was to find the equation of the perpendicular bisectors. Once we had that, we could then find the point of intersection. Once we've got the point of intersection, we know the center of the circle, so we can work out the radius, and then we can give the equation of the circle. So here's the question we're concerned with, to find the equation of the circle which passes through these points. So let's begin with AB. We're going to need to first of all find the midpoint of AB, which is going to be minus 2 plus 2 over 2, 3 plus 5 over 2, which gives us the point 0, 4. I also need to know the gradient between A and B so that I can then work out the perpendicular gradient between A and B. Now the gradient between A and B is going to be 5 minus 3 over 2 minus negative 2, which gives me 2 over 4, which is a half. Finding the negative reciprocal of that gradient, I will find the perpendicular. So minus 1 over a half, minus 1 over half just gives me a gradient of negative 2. Now I've got a gradient, I've got a point, so I can find the equation of that line using y minus a y-coordinate is equal to the gradient multiplied by x minus the x-coordinate. So that becomes y minus 4 is equal to minus 2x, or rearranging 2x plus y is equal to 4. Now we've done that for the points A and B, we need to continue and do exactly the same process for the points B and C. We start by finding the midpoint of BC, which is going to be 2 plus 4 over 2 and 5 plus 1 over 2, which gives me the midpoint as 3, 3. I need to find the gradient of BC, which is going to be 1 minus 5 over 4 minus 2, which is negative 4 over 2, which becomes negative 2. So the gradient for the perpendicular is going to be the negative reciprocal of that, which just becomes a half. Now I can use that to find the equation of the line. I've got the gradient, I've got the point, so y minus 3 is equal to a half lots of x minus 3, or 2y minus 6 is equal to x minus 3, and rearranging this, I'm going to choose to say that that's minus x plus 2y is equal to 3. Now the next point, we needed to find the intersection of these two perpendicular bisectors. Well, how do we do that? That's just simply a case of solving simultaneous equations. So the first equation I had was 2x plus y equals 4. The second equation I had was minus x plus 2y equals 3. So I'm going to take all of the second equation, multiply it by 2 to give me negative 2x plus 4y equals 6, and then I'm going to add that to the top equation so the x will cancel out, and that will give me 5y is equal to 10, which is going to tell me that y is equal to 2. Now substituting that back in, I'm going to choose the first equation, so 2x plus 2 is equal to 4, so that becomes 2x is equal to 2, and x is equal to 1. So the coordinates for the centre of my circle are 1, 2. We are close to being finished now. I've got the centre of my circle. All I need at this point is the radius. So to calculate the radius, what I'm going to do is to find the length of the centre of the circle to any of the coordinates, and I'm just going to randomly pick the point B. So let's say centre to B. The length of that line is going to be the difference in the x's, so 2 minus 1 squared, plus the difference in the y's, which is going to be 5 minus 2 squared, square rooted, which gives me 1 squared plus 3 squared, which is the square root of 10. And finally, I'm ready to give my answer. So the equation of my circle is going to be x minus the x coordinate of the centre plus y minus the y coordinate at the centre is equal to the radius of my circle squared. Or I could write that down as x minus 1 squared plus y minus 2 squared equals 10. That's a lot of working. It's seemingly straightforward, but it takes a long time and we have to hold our accuracy throughout.